ASAP can be used to analyze the propagation of light through optical fibers and do calculations on fiber coupling efficiency as well as mode calculations. Let's take a look at propagating light through an optical fiber. In this particular case, what we're going to do is define a couple of grin rods and put a coupler in the middle, and then we'll look at the output distribution coming out of the optical fiber. And we use this to determine the fiber coupling efficiency. So let's run a file and take a look at the analysis. Again, the file consists of a couple of grin rods. We have a fiber coupler in the middle. We've defined an input energy field, and we'll look at the output energy field after it's propagated through the second grin. Let's take a look at the analysis. In this particular case, we use Gaussian beam decomposition, and we defined our input electric field, and we can get information about the electric field as it leaves the second component. We can look at the three-dimensional false color plot or isometric information, and this is the information about the electric field at two different locations, the input and the output. From this, we can get information about the fiber coupling efficiency, the shape of the wavefront. This is good for a large mode type fiber or multi-mode type fiber. If we have a single mode fiber or very narrow core, we're going to need to use a different technique for propagating the wavefronts. We're going to have to use, for instance, a beam propagation method. So let's show you what this type of analysis would look like. So again, let's run the file. And in this case, what we have is a fiber. We can look at the analysis in 2 or 3 dimensions. We'll just look at a 2-dimensional output. So what we're going to do is effectively do a slab waveguide. And we have one mode at the input side, and it's going to partially couple into 2 modes as it goes through the waveguides. There's our input mode. And here's at the output. What we see is we have the light almost evenly coupled into 2 separate output modes, with 50% of the energy in one mode and 48% in the other mode, for a total efficiency of approximately 98%. Some of the other information we can look at is, although I will admit this is a bit hard to see, this is the light actually propagating through our fiber, the length of the fiber, and what we can do is by moving our cursor, we can see what the shape of the modes or the wavefront is at different locations within that fiber or this waveguide.